Buenos días con todos, los saluda Valeria Burgos, parte del equipo P.I.S. Concreto. El día de hoy nos encontramos en la 50ª edición del World of Concrete y tenemos la oportunidad de conversar con el doctor Tyler Ley, reconocido profesor e investigador en el Oklahoma State University, con más de 20 años de experiencia en ingeniería estructural y de materiales. Él además tiene participación activa en los comités técnicos del ACI de durabilidad del concreto, ciencia de los materiales, dosificación del concreto y sostenibilidad. Hello, Mr. Ley. It's a pleasure. Thank you so much for your time. We really appreciate it.
No problem. Glad to be here.
Okay, so, well, we're now in this 50th edition of the World of Concrete. Would you like to tell us your impressions regarding it?
I love the World of Concrete because it's a place where people come together to try to be better, to learn better, to make concrete better. And so this is where they all gather. So it excites me. And I think it's amazing that they've been doing it for 50 years. And I'm excited that I think it'll be going for at least 50 more or beyond. I think there's so much more to learn and more to do because I think concrete's the greatest material on the planet.
I know. Not only for the industry, also for the academia,
Yeah.
right? So you're worldwide known because of all the research projects you have done. Since topics from air influence, growing compounds for concrete, and so on. Would you be so kind to tell us where does your interest in concrete begin?
So when I was an undergraduate at Oklahoma State University, the same place I actually teach at now, a gentleman came to visit from the Army Corps of Engineers. His name was Bryant Mather, and he gave this talk, his technical talk, and just shocked me, just blew me away and made the hair on my neck stand up for like 3 days. And so I knew I was interested in concrete then I just took more classes, and I think I just fell in love because it's so simple, it's so powerful, it helps so many people.
I know.
It's just like, what else?
What was the topic that you were like that amazed with?
You know, I think it was the versatility of concrete. I think it was that you can make it flow like water, or you can make it like insanely strong. You can make it just do so many different things. I think I was just like, how is something so simple that complicated, that versatile, that just I don't know, amazing. I just blown away.
I share the passion also that actually I work in that. But that would be something we're going to talk about later. When talking about concrete, it is impossible to avoid mentioning the influence of the apparative process on the final quality. I saw a video where you mentioned that using water curing you can double the lifespan of a bridge deck. Could you explain to the audience about the impact of curing on the durability of the structure?
So concrete needs water when it reacts. Mm-hmm. And so when we cure concrete, we do our best to keep as much water in as possible. Mm-hmm. But when we use something called wet curing, that's where you put like blankets that are wet or some other fabric that are wet that's on top. It actually holds that water on top for extended periods of time, and that water will penetrate over time, and it keeps feeding that reaction again and again and again. So the reaction keeps going and going. Concrete gets stronger. Concrete gets more dense, more durable. That's why it's so powerful, and it's so easy. You just have to keep water on top of it.
That's right. Well, with all the times you have seen, right? Mm-hmm. And also, how can we verify the effectiveness of a curing process?
How can we verify the effectiveness of a curing process?
Mm-hmm.
That's a good question. Well, we can take the concrete, we can cut it up, we can try to dry it and see how.
It's more invasive. Right?
Well, we can try to dry it and see how hard it was to get water to leave, right?
Uh-huh.
Because if I've done a really good job curing, then it's dense, so nothing will come out, right?
Mm-hmm.
Then I can try to add water back into it, and if it's hard for that water to go in, then we've done a good job curing. We keep that structure tight and small. Mm-hmm. We can also add chemicals to it and see how fast they go in. All this can be measured. All this have been quantified, and I've done a lot of this work in the past and published papers on it. So you don't have to do it anymore. You could just read my my work about it.
Thank you. That would be very simplified, right, for everybody that is involved in this problematic. Also, how a poor curing can increment the speed of ion penetration to our concrete matrix?
So when we don't cure the concrete well, then it's like making a cake, but not putting icing on it. Like, would you make a cake without icing? That would be just a waste of a cake, right?
Right, all
It'd be
the
like,
frosting in it.
it'd be like bread. You want to put the icing on it, right, to finish it.
Right.
That's what curing does. When you don't cure your concrete, that outside layer of the concrete is like damaged. It's like not as good as it could be. And so it allows outside chemicals to get into that concrete.
It's all porous, I guess,
Exactly.
and it's easier to, lose water, lose humidity, and
Yeah.
can be very detrimental for
That's
the
right. And that's arguably the most important part is that outside surface.
Exactly, because that's what you get in contact with, all the exterior, right?
Exactly.
Which are the difference between curing compounds? Would you have any specific?
What are the differences between curing compounds?
Like classification.
Yeah, so there's different curing compounds definitely perform differently, and again, I've got some papers and videos about it. And usually, the short answer: the ones that are more expensive usually perform better than the ones that are less expensive. Usually. But and then the more you put on, the better it does. And the recommended dosage that they have is usually pretty good. And so we could talk more specifics if you wanted to, but that's kind of the simple answer.
That's very interesting. Yeah, well, we're trying to reach all the kind of audiences, so maybe we shouldn't get that into right now.
But I've got videos about it or papers about it if you want to learn more.
I have watched your videos, actually, are very interesting. Reminds me of a professor I have in my Master of Material Science and Engineering.
Very cool.
Okay, so let's keep going with the questions. Other thing that causes a headache when concreting are cracks, right? Could you explain us a little bit about the most recurring kind of cracks? And the ones, well, first that.
The most common cracks, I think it depends on the application, but usually it's drying shrinkage for the most part. That's where the concrete dries, wants to change dimension, and it's held. That'll cause a crack to form.
Okay. So exactly, the next question goes in that path. The ones that the cracks are because plastic shrinkage and drying shrinkage?
Yeah, those are two different ones, and it depends where you're at. Plastic shrinkage happens where it's dry and hot, evaporates a lot, but it only happens usually in part of the year. And then drying shrinkage happens throughout all the rest of the time.
Yeah. You're giving a conference actually about using fibers on slabs. I think that was you just get out of, and which is closely related with crack prevention. Right?
Yes.
Could you explain us how the different types of fibers, micro and macro, works on reducing different kinds of cracks at different ages of the concrete?
Yeah, so we're talking about plastic fibers right now, and there's micro and there's macro. So there's microfibers, and they do a great job when the concrete is fresh, when it hasn't hardened yet. And so if you get cracks when your concrete is still wet, like the first 6 hours or so, then microfibers are for you. They're great, and you get to use them at a pretty low dosage, and they'll stop that issue. If you have cracks that form in the hardened concrete, then macro plastic fibers, or steel fibers are what you want in that application.
Amazing. Well, actually, I think maybe you can use both, maybe for solving the problems in the short term and in the long term.
Sure.
Right?
You using them together are great if that's what you need.
Amazing. Okay, so when talking about long-lasting concrete, what are the main influence parameters in your opinion?
Concrete durability really is dominated by water to cement ratio, use of supplementary cementitious materials like fly ash and slag and things like that.
Okay.
Minimizing cracking. And then if you have freezing and thawing, you want to make sure you have air bubbles in the concrete, right? But you really have to understand the environment that the concrete is going to go into and then design it appropriately.
That's very interesting. But, well, actually that's, as everything, it depends, right?
Right.
It depends in the weather, depends in the time.
It does depend, but those are some of the tools you can use.
Thank you. We know that some people tend to relate water-cement ratio to durability properties.
Yep.
But it's not always true, right? As long as we have short water per cement radius, but high permeability. For example, what do you think about? What advice could you give to the contractors to prevent their structures from pathologies affecting their durability?
I think just be careful about how much water you add. If you can, the lowest amount that you can add, the best usually. Obviously, we have to make concrete workable and placeable, but don't use too much water.
Okay. Okay. So, what is the impact that long-lasting concrete has on sustainability?
So when you can spend money or you can spend carbon to build something, you want it to last as long as possible.
Of course.
Because that means you get to like take that cost and spread it out over as much time as you possibly can. And that's where concrete thrives. That's where concrete is so good, is that it's so durable, it's so long lasting. And so that's a great place for us to spend our money and our carbon, is to build concrete infrastructure, concrete buildings to help everybody around us last as long as possible.
That's right. Everywhere you went, right? From Peru to the U.S.,
That's right.
All around the world. Okay, so last but not least, when talking about innovation, I have seen some of your videos talking about 3D printing. What are your expectations for the future about this system?
I think 3D printing is the future. I think what people are doing now may not look like what it looks like in the future. I think it's a step on the journey, but I think 3D printing is extremely powerful, especially, and it all depends on how much labor shortage you have. If you have a lot of labor shortage, then I think 3D printing is powerful. And if you have plenty of labor, then maybe it's not for you. You know what I mean? I think you just have to figure out on different applications what it can do. But I can tell you that eventually it's going to be able to do some pretty amazing things.
Yeah, that's right. Well, this is more in general, but I wanted to still ask to you, which have been your biggest professional challenges, and how did you face them?
My biggest challenges, I think some of my challenges have been that I always have to remember to take care of my health. And I always have to remember to take care of me. Because if I don't have my health and I don't have me, then
cannot help anybody.
I can't help or serve anyone else. So I think that's been a great big lesson. I think another big lesson is that I don't have to be everything to everybody. You know what I mean? I just have to be what I need, and then it'll all work out along the way. If I can help other people, then that's great. So those are two things that I've learned.
That's right. That's right. Yeah. As long as you follow your path, your vocation, right? I think if you are doing the correct things, you are going to able to inspire without even wanting to do other people and
I agree.
actually teach them.
I agree. Thank you so much for interviewing me. I really appreciate it. I have to go and teach another class right now.
I finished. It's just before ending this interview, would you like to send some greetings to our followers in Latin America?
I would just say, hey, thanks for what you do. I think that we need everyone working together. And concrete is this amazing gift that you're giving to your kids and your grandkids and your neighbors and your family members and your friends and even people that don't even know that you're giving it to them. You are. So thanks for doing what you're doing. And I hope I can help you and support you. I hope you'll watch my YouTube channel and just keep being awesome and go concrete, baby. Go concrete.